Okay, so this is a video on sketching cubics and quartics, which my normal maths class found quite challenging, and my further maths class haven't even seen yet, so this is definitely going to be an interesting one. First of all, we need to identify what it is that you need to be able to sketch a cubic or a quartic. There are 4 things, 3 of which you know about. Well, further maths guys might know about the 4th one. You need to know the shape of the graph, which I call orientation. You need to know the roots, which is another way of saying you need to know where the graph intercepts the x-axis. You need to be able to identify the y-axis, the intercept on the y-axis, which you can identify the y-axis is that tall thing that's vertical. And also use turning points. When I say turning point, written down there, it probably should have turning points. But you've not got the information or the skills yet to do that unless you've read ahead or watched my videos, in which case, good boy. Now, let's have a look at this first one here. We're doing the graph y equals x plus 1, x plus 2, x plus 3. The clever ones of you will know that that is a cubic, because when you expand it, it's x to the power 3 is your highest power. What sort of shape does it have? Because it's a positive cubic, you have the shape as it's given there, that sort of S shape where you start low and you go high. What are the roots? The roots of the equation are when you make the equation equal 0, so obviously that means the roots of this particular one are minus 3, minus 2, minus 1. If that's not obvious to you, just think of it this way. If the whole thing equals 0, and there's 3 things multiplying each other, one or other of them has to be 0 to make it a whole thing equal 0. So either minus 1 to make the first bracket 0, minus 2 to make the second bracket 0, minus 3 to make the third bracket 0. You multiply the numbers inside the brackets to find what the y-intercept is. Why? Because if you expand it, that will give you the number, and you remember the number is the y-intercept. So I've got my 3 points there, minus 3, minus 2, minus 1. I've neglected to label the y-axis 6, and I'd lose a mark for that, so don't be stupid like your teacher. Make sure you've got a 6 there on the y-axis. You plot the points, you make them follow the shape. Bob's your uncle, you've done the first graph. Not too bad, not too shabby, I hope you agree. Part 2. What happens when you've got a repeated root? That means basically in this context a bracket with a squared or a bracket with a power 4, which you won't have to deal with unless you're very unlucky. With that, even then that'd have to be a quartic, wouldn't it? Shape stays the same, because when you expand that, you'd get an x cubed. Only 2 roots this time, but the one at 1 is repeated. Now, we had that kind of philosophical discussion with my class. Does a repeated root really a different root? I disagree with the majority of mathematicians, as I'm sure you're not surprised, me disagreeing with something amazing. But nevertheless, we'll deal with it as it is. The y-intercept is minus 1, and 2. So if I multiply those out, I get 2. What do we notice is different here? When you've got a repeated root, when you've got a squared, it doesn't pierce the line, it bounces off. And that's true for any even powers. If that had been x minus 1 to the 4, again it would have bounced off, but had it been 3, it wouldn't have bounced off, it would have pierced the line. Again, you follow the shape, and you just take into account that it does bounce off the line. That's all really here. Let's look at this one here now. Here we've got something slightly different, because we've got a negative x cubed. If you expand that bracket, x times minus x times x is negative x cubed. That just inverts the shape, or reverses the orientation, if you like to talk the way I talk. X-intercepts we find by just making things 0 again, and the y-intercept is going to be the numbers multiplied together, so minus 6. Again, plot your points, join them up in the shape you know it must be. What's hard? Not a lot in my opinion. We've got a quartic at the bottom. Quartic has the shape of either a W or an N in general. Now, there are exceptions to that. If you did, for example, x to the 4, you get something that looks remarkably like a quadratic. It is what it is. The argument around that is like all 4 points are plotted, so superimposed on each other. I don't really want to get into that, to be honest with you. Let's have a look at this one here. You know it's going to go through minus 1, minus 2, 1 and 2. So I've plotted those points. If you multiply the numbers, it will go through, you'll get the number that it goes to the y-axis, so 1 times 2 times minus 1 times 2. You should know your shapes. So this is a positive quartic, so it's going to be a W shape. Join up your points, and again, once again, Bob's your uncle. No repeated roots, so no bouncing. So I'm hoping those 4 examples clarify the point. If they don't, put a comment in the video. It's good to see so many people actually watching the damn things. It actually makes it feel a little bit worthwhile. To give you a time check, it's like 10 to 2 in the morning. I'm here doing this because I promised I would do it. So the more you give back to me, the more I feel like doing things like